Let's have a look at question 6 in this video. So an industrial plant wants to discharge no more than 1000 liters of wastewater per hour on average. Okay, now what do we have here? We have a random sample of 9 measurements. The average amount based on this sample is 1200 liters. Okay, the standard deviation of the population of this distribution of waste is 400 liters per hour. The hypothesis that we're testing is whether the mean of this distribution is 1000 liters or different than 1000 liters. The p-value corresponding to the test is the following, true or false. So we have the data over here, the hypothesis as well. Let's draw it on a graph to understand what we're doing, what the p-value is, and then we're going to solve the math to see how the numbers look like. So we're going to have here the distribution. We're going to have this distribution of liters of waste, right? It's gonna look like that, normal distribution. Under the null hypothesis, we think that the mean is 1000 liters, so we have 1000 liters in the middle of the distribution. But then what we find is based on our sample data that our sample mean is 1200, so it's over here. Now what the p-value is gonna be the probability that we obtain this result by chance. So at least obtaining this result by chance. And since this is a two-sided test, we have the same p-value, the same tail on the left side. So we're gonna have a result over here as well. We're interested in finding both tails. Now how can we find out tails? How can we find out probabilities? By looking at proportions. So we're gonna standardize this distribution into the normal standardized z distribution like that, which has a mean of 0. So we're gonna have a mean of 0, and what we're interested in is finding out the value of 1200 liters in standard units, so in the z-score, so to speak, and then based on that we're gonna calculate one tail and multiply it by 2. So we're gonna calculate this z-value over here. Now what's gonna be the z-value? That's the difference between the sample mean from the population mean in terms of standard errors, which is sigma divided by square root of n. Hold on, sigma divided by square root of n. Let me write the entire formula. Now let's solve and substitute the data. What's the sample mean? That's 1200 liters. So we have 1200 minus the population mean under the null hypothesis, which is 1000. So minus 1000 divided by the standard deviation of 400 over square root of n, which is square root of 9. Now if we solve the math over here, we get a result of 1.5. So the z-value that we find is 1.5. But then remember, this is a two-sided test, so we're interested in on the other side as well, 1.5 over here. We want to have also the value of minus 1.5 symmetrically over here. Now we can find out the p-value of having a z-score less than or equal to minus 1.5 by looking in the distribution. So the probability that z is less than minus 1.5 is going to be equal to 0.0668. So that's 0.0668. But the entire p-value of this test, because this is a two-sided test, we must take into account both tails. So we're going to multiply 0.0668 times 2. We multiply this times 2, and that's equal to 0.1336. And based on the answer key, the tail is only 0.0668, but that's just one tail. So the answer to this question is false, and we are done.